Hi guys, this week's Newsella article is the diabolical ironclad beetle is almost unsquishable. The caption reads, "The diabolical ironclad beetle looks sort of like a rock, and it's almost as unbreakable. Thanks to the intricate links between different parts of its exoskeleton, this beetle can withstand getting run over by a car." There is a beetle that is so strong it can hold 39,000 times its own weight. That would be like a human holding 40 battle tanks. The beetle can even survive getting run over by a car. This beetle is known as the diabolical ironclad beetle. Its strength comes from its exoskeleton. This is a hard outer body covering. It protects the beetle from animals that try to eat it. In October 2020, researchers published a study. They explained what makes the beetle's exoskeleton so strong. They found that it is made of pieces that link together. This keeps the insect from getting squished. David Casalis works at the University of California, Irvine. He is a materials scientist. This means he studies the structure of a material and how it is related to its properties. These scientists can design new materials or they can analyze existing ones. He says the diabolical ironclad beetle has a distinct shape. Other beetles are more rounded, but he says this beetle is low to the ground. It's also flat on top. Casalis and his team tested the strength of the beetle's exoskeleton. They found that it can handle extreme forces. A force is a push or pull in a specific direction. The diabolical ironclad beetle's key features. The scientists studied the beetle. They found that two key features that help the beetle handle extreme forces. The first key feature is a series of ridges. The beetle's exoskeleton has two parts. It has a top part and a bottom part. Each part has ridges. These ridges help the two halves stick together very well. It works like a very strong zipper. Near the front of the beetle, those ridges are linked together very tightly, but this is not the case near the back. They are not linked tightly there. I think they mean linked. That helps the shell bend more easily. If the shell can bend, it will not break as easily. The second key feature is a joint. It helps the beetle handle extreme forces. A joint is a stiff piece that connects the left and right sides of the beetle's back. The left and right sides zip together. Pieces called blades help them do this. The blades are made of very strong proteins. A protein is a long molecule, which is a group of atoms bonded together. When an animal tries to squish the bug, the proteins crack. Those cracks absorb or take in some of the pushing force. Then the cracks close up and heal. Studying the beetle's exoskeleton. These two features protect the beetle. Animals might swallow the beetle whole, but they cannot crack its shell. Scientists want to use these findings. They might be able to make materials even stronger. For example, they might be able to build stronger airplanes. Who knows what other critters might one day reveal amazing features? And your questions for the week. Number 1, which sentence from this section studying the beetle's exoskeleton explains why scientists want to know more about the diabolical ironclad beetle? A, these two features protect the beetle. B, animals might swallow the beetle whole. C, scientists want to use these findings. Or D, they might be able to make materials even stronger. Number 2, read the introduction, paragraphs 1 through 6. Select the paragraph from the introduction that explains how strong the diabolical ironclad beetle is. A, there is a beetle that is strong is so strong it can hold 39,000 times its own weight. That would be like a human holding 40 battle tanks. The beetle can even survive getting run over by a car. B. This beetle is known as the diabolical ironclad beetle. Its strength comes from its exoskeleton. This is a hard outer body covering. It protects the beetle from animals that try to eat it. C. He says that the diabolical ironclad beetle has a distinct shape. Other beetles are more rounded, but he says this beetle is low to the ground. It's also flat on top. D. Casalis and his team tested the strength of the beetle's exoskeleton. They found that it can handle extreme forces. A force is a push or pull in a specific direction. 3. How do blades on the beetle's back affect its ability to handle extreme forces? A. They release proteins across the beetle's back to make it rigid. B. They lock tightly together and become stiff when a force is applied. C. They are made up of proteins that crack and absorb a pushing force. D. They spread apart and disconnect from the ridges on the beetle's back. 4. Why are the ridges at the back of the beetle's body farther apart than they are at the front? A. Because the front of its body is more important. B. To let them bend more easily when under force. C. Because there are fewer of them near its backside. Or D. To help it move more quickly and easily.